All right, let's jump right in. Today we're doing a deep dive into the coastal ecology of Western Canada.
We are, and we're focusing on something you might not expect.
Yeah, our mission is to sort of unpack this massive and really unexpected destructive force that's just hiding in plain sight.
Hiding right along the high tide line. And the culprit, which is what's so fascinating, is the drift log.
The drift log, something you see all the time and just assume is a natural part of the beach.
Exactly. But it turns out these logs are a major driver of habitat loss, particularly on the rocky shores of British Columbia.
And the scale of this it's just hard to get your head around.
It is. I mean, like a conservative estimate suggests there are about 450,000 logs currently lining the shores of Vancouver Island.
Just Vancouver Island, wow.
So when you hear a number that big, the first question has to be, is this natural?
Right, is this just how it's always been?
And the research says, no, not even close. This is an accelerated, a human-driven problem.
How accelerated are we talking about here?
Well, historical analyses show an estimated 800% increase in the number of logs since before European settlement.
800%. Okay, that is not a natural fluctuation.
Not at all. And that trend correlates directly with the expansion of industrial forestry in the region.
So we've got a likely cause.
Yeah.
But is there hard evidence, a smoking gun that ties these logs to industry?
Oh, absolutely. Field surveys went out and looked at hundreds of these logs on the shore.
And what did they find?
They found that nearly 60%, 59.2% to be precise, had clear saw cuts.
Saw cuts, so definitely not a tree that just fell over in a storm.
Exactly. And to compare, only about 17% of the logs showed any sign of a natural root system. The evidence is just overwhelming.
Okay, so these logs shouldn't be there, but if they just sit on the beach, I mean, what's the actual harm?
That's the crucial point. They don't just sit there.
They move.
Constantly. Every storm, every big high tide, they get re-mobilized. Over 90% of them can be moved in a given year.
So it's not a static problem at all.
No. Tagging studies actually confirm this. They found 55% of the logs they tagged moved within just 1 month.
So what you have is this army of almost 500,000 logs just grinding and rolling along the coastline.
It's like a massive repetitive sandpaper effect. That's the mechanism of destruction, abrasion.
And I imagine the victims are the creatures that can't get out of the way.
Precisely. The key intertidal foundation species, like large barnacles, they just get scraped right off the rocks.
And is the impact noticeable?
It's dramatic. On exposed flat surfaces, the research found up to 80% fewer large barnacles than in protected spots like crevices.
So the only defense is the actual roughness of the shore.
Right. It's rugosity. But even with that, they found that abraded areas, basically permanent barnacle scars, made up, on average, a third of the rocky areas they photographed.
And losing the barnacles has to have a knock-on effect, right? It can't just stop there.
It's a huge cascading effect. Because those large barnacles, they create this incredibly complex habitat.
Like a tiny protective city on the rocks.
A perfect analogy. And when you scrape that city away, you also wipe out the entire interstitial community.
Which is what exactly?
All the tiny creatures, the amphipods, the worms, the small mites that live between the barnacle shells.
The bottom of the food web?
The absolute base. And when you remove that, you directly impact the larger animals that feed on them.
Like the shorebirds.
This is where it connects to the bigger picture. The authors link this habitat loss to the documented global declines in shorebirds that forage there.
Such as?
Birds like surfbirds and black turnstones. The surfbird population, for example, has seen a 50% reduction since the 1970s.
So to synthesize this isn't a one-off disaster like a heat wave.
No. This is a chronic, year-in, year-out cyclical threat.
A threat that prevents these complex intertidal communities from ever really recovering.
They just never get the chance. And the situation is likely to get worse.
Why is that?
Well, with global warming, the forecast is for more intense storms.
Which means more energy in the waves to move these logs around?
More energy, more remobilization, and even faster degradation of these rocky habitats.
Which leaves us with a really important final thought for you to consider.
Since this is so clearly a human-driven physical disturbance, what fundamental regulatory or ecological steps are necessary to manage this persistent tide of wood debris?